So we're moving right along with sorts. Again, we started with 3 generic categories of sorts. Anybody remember what those 3 generic categories were?
Conrad here.
What was that?
I just say Conrad here, that's all.
I saw Conrad, thanks.
Selection.
Selection, yeah. I selected a value and moved it to the spot I wanted it to be in. The bubble sort, what were we doing with the side-by-side ones? We were,
Swap comparison.
yeah,
Comparison.
swapping, we were exchanging. Better word might be an exchange sort. Finally, the last one we really haven't talked much about yet is the
Insertion.
Merge.
insertion sort, right? So keeping again these 3 basic ideas of selection, exchange, insertion, we're going to cover 3 chapters in, or 3 sections in NIOP today, 3 different types of sorts, and each one of these is going to end up falling into one of these categories, okay? And the first one we're going to take a look at is one called a quick sort. And in order to do a quick sort, we're going to use something called a pivot. All right, so here we go. We you know, I still go back to the nice simple bubble sorts or something, but they're in so here's how we're going to do this. We're going to start with this first value, the 75, and we're going to make that our pivot, okay? So in a moment, that pivot is going to be put into a location so that all the numbers smaller than it are to the left and all the numbers larger are to the right. Again, we're going to use this concept of a swap. So taking a look at it, is 70 less than 75? My answer is yes. So I leave there and I move to the next spot. Is 80 or 65 less than 75? Yes. So I move to the next spot. Is 84 smaller than 75? The answer is now no. So I go to the end. Now, a moment ago, I said the 75 is going to be in a spot where all the numbers smaller than it are to the left and all the numbers to the right are larger. So just like I was going through here checking to see if they were smaller or not, and if they were, I kept going. Now I want to see one just the opposite. So is 68 less than 84? Or excuse me, is 68 less than 75? The answer is yes. So I'm going to swap these, 68 and 84. Now, since I did a swap, I'm going to come back and start again. Is this 98 less than the 65? No. So I pause there. I come to the end. Is 81 less than? No. Is 61 less than? The answer is yes. So I swap them. 61. This becomes 98. Come back to the left. Is it less than? Nope. So I stop there. I come here. Is it greater than? Nope. So I swap them. This becomes 55. This becomes 70. Why am I writing them up there? 55. And that becomes 78. The next one, 100. I stay there because it's greater than. I go to the end. 93 is greater than. 100 is greater than. So now I'm going to stop because these two guys are the same. And at this point, I'm now going to move my pivot to the middle. So now I'm going to switch this guy and this guy. And now I have 55, 70, 65, 68, 61, and 75, which was my pivot. Over here, I have 100, 93, 55, excuse me. So I'm doing this in pencil, 78, 98, 81, and 84. Okay, so I swapped them till I got to a certain point that matched. Because it was greater than, I'm going to switch the one before it with my 75. And now I know one thing, 75 is in the right spot. Okay. Now, what do? I'm going to repeat that process, but instead of this big list, I'm going to do it with this list, and I'm going to do it with this list. So here, my pivot is 55 when I'm looking at this list. Is it less than? No, so I stop there. Greater than? Yes, yes, yes. Uh-oh. So now what do I know? 55 is in the right spot. What's to the left of it? I would now do a quick sort on. What's to the right of it? Well, there's nothing to the left of it, so I'm done. To the right, I now have a new pivot, 70. Okay. Is it less than? Yes, keep moving. Yes, keep moving. Yes, keep moving. I reached the end of the list, so I'm going to swap these. I now have 61, 65, 68, and 70. This was my pivot, so I send the list to the left and I send the list to the right. There is no list to the right. I have a list to the left, and I'm going to keep proceeding that way. Over here, 100 was my pivot. Less than, less than, less than, less than, less than. So what do? I'm going to swap 100. I'm going to swap 84. 100's now in its right spot. Everything to the left is a new list that needs to have a quick sort. Everything to the right, which isn't anything, now has a quick sort. If I take a look at to the left, I have 84 as my pivot. This is greater than, stop. This is less than, I switched those. 81, 84. This is less than, that's good. This is greater than, stop. I come back, I'm going to switch those. So now this becomes 84 and this becomes 98. Okay, so I have a pivot of 84. Here's 81. Why do I have a second pivot of 84? Oh, I already swapped them. Now I have two 84s. Hold on a second. This was an 81. Okay, so the 81 and the 98 switched. This is still 80. Can I redo that one, please? Because I wanted to confuse you. My pivot is now 100. I moved it over to here. That's good. So this was 84. And now this is the left list. So it's 84, 93, 78, 98, and 81. 84 becomes my pivot. Stop, go to the end. Stop, switch them. This is 81. This becomes 84. Less than, greater than. What the heck? This is 93. I'm being a real clown here. I apologize. We switched to 93 and 81. Come here, it's greater than. Here it's greater than. Where do I now swap the 84? With the 78. So I have an 80, a 78. I do know what I'm doing, folks. An 81, an 80.
Early morning, right?
What's that?
Early morning, right?
Yeah. Well, see, this is one of those lessons where I used to have 3x5 cards, and I'd have all these numbers on 3x5 cards. So then we could just move the cards. Now, we couldn't see back to what was going on, but we could do it. So now from 84, its left is going to go as a new list. Its right is going to go as a new list, and so on. And eventually this would all get sorted out. Questions on the quick sort? Are you confused about the quick sort?
Seems
I would say something that helps me is there are like GIFs and stuff like that online of how this stuff works.
Yes.
gifts.
To watch the videos, yes.
Yeah, I have one that has like 6 or 7 different algorithms on it.
Okay.
It's just a GIF that continuously plays with all the different sorting algorithms.
Right. Okay. Good.
Post it in discussion.
Oh, yeah, I could do that.
Matt's here. Mark's here. Rashawn's here. Holy cow. I don't see Dylan, Cassius, or Jill Kumar. And I think Jill Kumar dropped. So who are we missing? Dylan and Cassius and Maria. All right. Any questions on the quick sort? Do you need to see it again or not? Moving on. Okay. Number 2, it's called the merge sort. The merge sort. Well, first of all, we're going to talk about how merging works. And merging is going to work. Ooh, look at all that white stuff. Merging works this way. I take 2 sorted lists. I'm going to go through the list one at a time. And I'm going to compare. And whatever's the smallest gets merged into the new list. So I start at the beginning. 1 and 2, what's smaller? 1, yeah. Erase that. I move over. 2 and 9. The 2 is smaller. So I move over. 5 and 9. The 5 is smaller. 9 and 11. The 9 is smaller. 10 and 11. The 10 is smaller. 11 and 20. 11 is smaller. 16 and 20. The 16 is smaller. So as you can see, I'm slowly moving across each of these arrays, creating a new array. 24 and 26 is 24. 25, I'm at the end. 26. Okay, so I take 2 small lists. Just looking at those, I want to merge them to get a new list.
So you'd have like 2 arrays for this.
Right, well, 3. I have
Oh,
this
yeah,
array,
3.
this array,
Yeah.
and then a resulting array.
Yeah. Okay.
All right. So what are you wanting to put the GIF under? Anybody?
It's the sorting GIF with all the different sorting algorithms on it.
Why don't you put it in, I think there's one on the discussion board that's called sorting.
I didn't see it. I'll double check.
Okay. Okay. So I'm going to now do something called a binary merge sort. And in order for the binary merge sort to work, the number of items must be a power of 2. And if you count up the items, you see that there are, in fact, 16 of them. Right? So that's a power 2. So I'm going to be able to use the binary sort. Galen, are you with us, or should I give you another minute to catch up?
No, I'm following.
You're fine? Okay, so we're going to take a look at this whole thing called a binary sort. And the first time we're going to go through, we're going to take this list and we're going to alternate it. So I'm going to go 75 to make 2 new lists. 55, 15, 20, 85, 30, 35, 10, 60, 40, 50, 25, 45, 80, 70, and 65. So again, the idea up here was I had 2 arrays and I merged them to make 1 array. Okay, so now I'm going to take these and I'm going to merge them, but I'm only going to merge them into groups of 2. So I'm going to take the first one in each and merge it and create a new list. 55, 75, 15, 20, 30, 85, 10, 35, 40, 60, 25, 50, 45, 80, 65, 70. Now, I merged them as pairs. In fact, I merged them as sorted pairs. So what I'm now going to do is make 2 lists, but this time, instead of going 1 at a time, I'm going to go pairs at a time. 55, 75. Now I'm going to go to my second array, 15 and 20, 30 and 85, 10, 35, 40 and 60, 25 and 50, 45 and 80, 65 and 70. So up here, I did one at a time to create pairs and made a new list. Now I'm doing two at a time, but instead of creating pairs, I'm going to create groups of 4. So I'm going to do a merge on just these 4. Then I'm going to merge on just these 4. So now I'm looking at 15, 20, 55, 75, 10, 30, 35, 85, 25, 40, 50, and 60, 45, 65, 70, and 80. One array made it 2 lists. One array made it 2 lists. Now up here I did ones. Now I'm doing groups of 2. Now I'm going to do groups of 4. 15, 20, 55, 75, 10, 30, 35, 85, 25, 40, 50, and 60, 45, 65, 70, and 80. Now you see the relevance of why we were doing ones, then twos, now 4s. And finally, I'm going to have 2 groups of 8. I'm going to have 10, 15, 20, 30, 35, 55, 75, and 85. So I merged group by groups of 4, 25, 40, 45, 50, 60, 65, 70, and 80. Now I'm going to take those and I'm going to write this line, so my 1 is now going to become 2, but it's this line over this line. And then eventually I'll do one final merging of the list. So my first array, I could separate these out as I go through. 1s to 2s to 1s to 2s. Sometimes just drawing those lines helps things. So now I'm at this. I'm going to take my single one and I'm going to write it as 10, 15, 20, 30, 35, 55, 75, 85. Yeah, it's kind of looking like 25, 40. What do we got? 45, 50, and 60. 45, 50, and 60. 65, 70, and 80. And now I'm going to do one final merge to put them all together. So it's this concept from up here at the beginning. I have two sorted lists that I want to merge together. Here, the sorted lists were of length 8. Here, the sorted lists were of length 4 that I merged together. Here, the sorted lists were of length 2 that I merged together. And again, up here, the sorted lists were of length 1 that I merged together. 15 and 20, 85 and 30, and so on. So then if I did one final merge, boom, I would have a list. It's called the binary merge sort. How we make it out?
Real quick, how fast is it?
I think it was n log n for you big O notation people. I have it in my notes, but when I condensed to this, I got rid of it. But I also have the book close by that I could look at it.
So what advantage does this have over like quicksort or?
Again, this is one of those where you'd have to start doing, really looking at the code, maybe checking out the big O notation. The other thing is, you could start with a sorted list and do this, maybe 100 numbers, do this and see what time it took. Then maybe try it with 1,000 numbers, see what time it, and 10,000 numbers. So
I'm just thinking because the other one just seemed like so much more graceful in a weird way.
Yeah.
And this just, it seems complicated.
Yeah. Well, you see, there is a pattern. And
Yeah,
again,
yeah.
this is one of those where, if I said, well, now you have to code the binary merge sort, you'd have to get the concept first of all. Quick question. Going back to your last program with the heaps, how many numbers were in that heap? How many candy store items were there?
Like 12.
12. Very good. What should the size of your array have been?
13.
Why 13?
Because 13 is a prime number.
Okay. But was 13 1.5 to 2 times the size? Because remember, it was saying you're going to probably have a lot of collisions with 13. But you are correct. We wanted a prime. So if I took 12, multiplied it by 1.5 or times 2, I'm looking at somewhere between 18 and 24. What would have been the optimal number for that array size? Give me a prime number between 18 and 24. It's less than 20.
17. Oh no, you said 18,
19.
24, 19.
19, yeah. So for that heat program, to make it work optimally, you should have had an array of size 19. Now, again, where did that come from? Well, as we saw in the book, it said empirical studies have shown that to use 1.5 times 2 times the size of the number of elements would be the optimal way to reduce a lot of collisions and make it easier to do the whatever probing you had, especially if it was linear or something like that. So that was just something that I wanted to come back and have a quick conversation about. And it was quick. All right, so that was the binary merge sort. Now, I'm going to take a look at a natural merge sort, which is going to be fairly similar, except we're not going to go by ones, then by twos, then by fours, because we may not have 16 items or 32 items. So what if I don't have that? What do I do? Well, we're going to do something called the natural merge sort. And what we mean by that is instead of breaking them up as ones, we're going to break them up as runs. Okay, so my first time through, instead of going 75 and 55, 15 and 20, 85 and 30, we're going to do runs of what's already sorted. So I'm going to start on this list, and the first thing I'm going to put in is 75. The next number is smaller, so I stop. Then I'm going to put in 55. The next number is smaller, so I stop. Now I'm going to put in a 15, but I can keep going. A 20 and an 85. And I stop. Now I'm going to do a 30 and a 35. And I stop. Now I'm going to do a 10 and a 60. And I stop. I'm going to do a 40 and a 50. And I stop. I now have 25, 45, 80, and I stop. I have a 70, and I stop, and a 65. So I just made my 2 lists. And this natural seems to be almost a little more sorted than the binary. But as always, we have to assume worst case scenario. And if these were already in descending order, would that be a major problem? An answer to that, oh boy, yeah. Okay, so now I'm going to do individual blocks. My first block goes until what? Till that item is smaller, right? So I'm going to compare this and this. 55, 75. Now I'm going to compare these blocks. 15, 20, 30, 35, and 85. These 2 blocks. 10, 40, 50, 60. These 2 blocks. 25, 45, 70, 80, And then I have an odd one at the end, 65. Made one list. Now I'm going back and make two lists, 55 and 75. So instead of knowing how far you want to go each time, we're going until a situation occurs, and that is the next number's less. So that's in my first list. I have 15, 20, 30, 35, and 85. I have 10, 40, 50, 60. I have 25, 45, 70, and 80. And finally, I have 65 out on the end. Merge these two with all of these. 15, 20, 30, 35, 55, 75, 85. What do I have next? 10, 25, 40, 45, 50, 60, 70, 80. And of course, 65 sits out there on the end. Merge this list with this list. Merge and nothing to merge it with. All right, so now I'm going to take my first list. I take this array and find my first new array. 15, 20, 30, 35, 55, 75, and 85. My next list is 10, 25, 40, 45, 50, 60, 70, 80, and then finally the 65. Yeah, 65 is a pain in the butt. Going to merge this list with this list, then this list with, and then I'm going to have to do it, looks like one more time after that. 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Do I got a 70 and a 75? Do I got an 80 and an 85? And then finally the 65. And as you can see, this is going to fill my first array. This is going to fill my second array. And then I would merge them to get the final sorted list. Questions? Any questions?
So what determines the length of the runs?
In this guy?
Or in any of them, really?
All right, so
Curiosity.
let's start with here. Tell me, where does this one go? Well, I know I'm starting by filling array 1. So array 1, it's bigger. Array 1, it's not bigger. So I switch to array 2.
Okay, okay, I get it now. Okay.
Yeah, okay. And again, this is one of those where writing down, playing with the math concepts to make sure that I got all of this well in hand before I try to start thinking this out.
Yeah.
Yeah. And how am I going to be checking back and forth between the two arrays? Clearly, I'm repeating things. You know, I'm going from 2 to 1. My merge, I'm somehow calling merge. You know, how am I moving across? So it would be the juggling of a whole bunch of stuff here. So conceptually, this is something for a third semester course. Programming wise, this is something that's, you know, a bigger project, maybe even a small group project kind of deal.
I don't know, that just seems simpler in my head than the binary.
Okay. Yeah. Except here, you may have to, you know, I'm thinking I have to keep going till I hit a certain spot. But in the binary, I'm doing my ones. Then the next time I automatically know I'm going by pairs. And next time I automatically know I'm going by 4s. So I'm eliminating a check on this.
Weird question. Would it ever be beneficiary to add numbers into a list that like are, you know, zeros in order to do a binary merge sort?
To add extra numbers.
Yeah, to, you know, make sure.
Yeah, I know what you're saying. Add a whole bunch of 999s to the end. Let me ask you this. What if I had 257 items. How many zeros would I have to add?
Oh,
Or
yeah.
999? I'd have to add 255 of them to get to the next power of 2. So if I had 257 numbers, right? My next power of 2 is 512. Because 256 is a power of 2, but we're over that. So to get to the 512, I'd have to fill in an extra 255 array spaces. Does that make sense?
Yeah, that's probably not the good idea.
Yeah, yeah. Yeah, and again, once you do this, you have it. Just like my 161s just wrote the program where they have the 4 different sorts already in 4 different methods. If they ever needed one, they could copy and paste. Except about a third of them did the 3 for loops instead of the 4 doing while. They got it off the internet, so now I have to deal with that next class kind of deal. Okay, so the merge sort, again, there's 2 different ones, the binary and the natural. The third sort we're going to take a look at today is called the Radix sort. The Radix sort. You're going to like this one. Okay, the Radix sort is going to work on filling these little tubs, these little containers or whatever with the numbers. And what I'm going to do is I am then going to rearrange the list and repeat the process. And I'm going to repeat the process for as many digits as there are in the largest number. So in this case, I'm going to repeat this process 3 times because these are 3-digit numbers. All right. The first time I go through, I'm going to take a look at the digit and I'm going to put the number in whatever container I want based on the digit, the first digit, the ones digit. So 64 is going to go and sit right down in there. Okay. The 8 is going to go down into here. 216 is going to go to this container. 512 is going there. 27 is going there. 729 is going there. 199 is going there. Here goes 550. Here's 343. Here is 125. Here is 93. And here is the ever popular 666. Okay. Now, from my understanding, the Radix sort helped back in the days when we had cards that were called punch cards, and every punch card would be numbered. So you could put them in a sorter afterwards and be able to sort them out and so on and so on. All right. So now I'm going to make a new list, but I'm going to go from left to right, bottom up. So my new list is 550, 512, 343, 93, 64, 125, 216, 666, 27, 8, 729, and 199. Took care of the ones digits. Now I'm going to drop them in buckets depending on the tens digit. Here goes 555. Here comes 512. Here goes 343. Out here is 93. Here's 64. 125. Again, I'm looking at the tens digit. Some of you are already going, well, yeah, that I could use integer division or modulus or integer division, something to come up. 666. 27, that's a 2. 8, that's going to go where? Well, it's going to come over here in this 0 column. 729 is going to go here. and 199 is going to go out of here. Bottom up, 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 8, 5, 12, 216, 125, 27, 729, 343, 550, 64, 666, 93, and 199. Bottoms up, up, up. Let's see, 008, 512, 216, because I'm using the hundreds this time, 125, 027, 729, 343, 550, 064, 666, 093, and 199. Bottoms up, 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 8, 27, 64, 93, 125, 199, 216. Who would have ever thought there would be this many different ways to sort a stinking list of numbers? Ta-da! Bottoms up, up, up. Questions?
How bored was somebody to come up with this?
Uh, you know what? This is probably one of those nighttime things where they wake up in the middle of the night, and yeah, it could be needs for different reasons. You know,
It
this.
didn't come out of necessity.
What's that?
It didn't come out of necessity.
Yeah, like this could have been because you're dealing with punch cards and you need a machine that could be able to sort and put them in different, and then you pick them out and run them through again, and they sort and then pick them out and put them in, they run through again, you know, depending by ones, digits, tens, and then hundreds kind of deal.
I'm just thinking, like, was it like a midnight epiphany where it's like, I got it.
Yeah,
I know how to do this.
yeah. Well, you know, they say, what's his name invented calculus during a plague or something.
Isaac Newton?
Yeah, he's stuck at home with nothing to do because of the plague. And, you know, that's why I was thinking coronavirus would have been great. People were stuck at home and bored, and all of a sudden, if you didn't have TV,
Yeah.
you know, or computers or anything, what you might be able to come up with.
True.
So,
Imagine the stuff you couldn't come up with without it, though.
right. Exactly. There's good and bad for both. Okay. Help me out. Which sort do you need to see again, or do you think you got them all?
I mean, I'm gonna be watching this video for a while when it gets uploaded, but
Yeah.
you know,
Yeah.
Yeah.
Pick one. We have time. Pick one. The quick sort, the binary merge,
Binary one. That one. 3D.
Binary
Yeah, let's
merge.
look that guy over again, please.
binary merge. How many numbers you want to do? 16 again?
Yeah.
that's a good number.
All right. Go ahead. Shoot 16 numbers at me.
5.
33.
5,
3,
33.
33, 3,
11,
11. That's 4. Go ahead.
17,
Yeah.
38.
38,
43.
43,
79,
79. That's 8. So we're halfway.
21.
21,
69.
69, 66, 58. 4 more.
97.
97, 28, 1.
3.
We already have 3. 6. Okay, I have 16 numbers in my list. First time through, I'm going by ones. So I'm going to let this list alone. I'm going to fill my 2 arrays. 5, 33, 3, 11, 17, 38, 43, 79, 21, 69, 66, 58, 97, 28, 1, and 6. So I went by ones because it's unsorted.
And it's not. This is not the part where we put it in a list, right?
Say that again.
This is not the part where we put it in a list, right?
Well, now I'm going to take these two and merge them as pairs. And I'm going to make a single list.
Okay.
Okay. So 5 and 33, 3 and 11, 17 and 38, 43 and 79, 21 and 69, 58, 66, 28, 97, 1 and 6. So now going from these guys being unsorted and one at a time, I created the two list. I made pairs. But now when I make my two arrays, instead of putting one at a time in the two arrays, I'm going to put two at a time. 5 and 33, 3 and 11, 17 and 38, 43 and 79, 21 and 69, 58 and 66, 28 and 97, and 1 and 6. Now I'm going to merge. So up here I merged singles. Now I'm going to merge list of length 2. So now I'm going to have 3, 5, 11, 33. I'm going to have 17, 38, 43, 79, 21, 58, 66, 69, 1, 6, 28, 97. Now I write my groups of 4, 3, 5, 11, 33, 17, 38, 43, and 79, 21, 58, 66, 69, 16, well, I'm sorry, 1, 6, 28, 97. So this time the list that I'm merging are going to be of length 4 because I know they're sorted. Just like up here I did them of length 2 because I know they're sorted. Merge them. 3, 5, 11, 17, 33, 38, 43, and 79. 1, 6, 21, 28, 58, 66, 69, 97. Now, instead of 4s, my list are going to be 8s, and then I would do one final merge.
So each time we're going through each one, we're sorting them and each.
We're merging them,
Yeah. Okay.
depending on which one's higher and which one's lower.
Okay. Gotcha.
So let me demonstrate that again. 1, 6, 21, 28, 58, 28, 58, 66, 69, and 97. So now I'm doing groups of 8, and I'm using that concept of merging. I start at the beginning. 1's the smallest. I compare 3 and 6. 3 is smaller. I compare 5 and 6. 5 smaller. 6 and 11. 6 is smaller. 11 and 21. 17 and 21. 21 and 33. 28 and 33. 33 and 58. 38 and 58. 43 and 58. 79. Okay. 58, 66, 69. I got rid of a bunch of them there. 79 and 97. And
So we're doing that for each time.
yes.
Okay.
Yes. When so
I
with
wasn't clear.
5 and 33,
Okay.
it became the 5. The 5 went, and I had the
Gotcha,
33
gotcha,
next it.
Okay.
So here it's 3.
That makes sense now.
Yeah. Okay. Good.
So this is going to sound like a dumb question, but the length of each array that we're like sorting stuff with is a 2 raised to some power.
Right. So here I didn't need to visually see the list, even though you can. I know it's only the first one in each. So that's this little group gets compared and done. I'm only going to use these two. That's the length of the list that I'm comparing. When I came down here, my list now became 2. So I'm going to compare these 2 lists individually. So I'm merging these 2 lists to get that.
So that first one could be described as like 2 to the 0 power, then 2 to the first power, then 2 to the second, then 2 to the third.
Yep. So my list size that I'm comparing is going to be 1, 2, 4, 8, like you said, powers of 2.
Okay. So that's actually simpler than I thought it was.
Yeah, I think it does make it a little easier than the merge, right? But again, it's based on the idea of the number of items you have has to be a power of 2.
For some reason, I was thinking it was just like it was dividing the length of the list instead of just being 2 raised to some power.
Gotcha. Other questions?